Welcome to GLASTcast. I'm Dave Thompson, a Deputy Project Scientist for GLAST. For a while, we've been telling you about all the great things this revolutionary telescope will do. Well, we're elated. GLAST is now in space. It has a new name, and it's keeping us very busy.
Liftoff. Delta rocket carrier flies to the Gamma telescope.
Last June, GLAST rose from a Florida launch pad on board a Delta II rocket and thundered into the sky. Launch day was very exciting. That ride into space was the mission's riskiest and most dramatic moment. For 2 weeks following launch, controllers carefully checked out the spacecraft's various systems. Could GLAST communicate properly? Did it know where it was pointing? Were the solar panels and batteries providing enough power? Once we knew we had a healthy spacecraft, it was time to turn on the two science instruments. The Large Area Telescope, or LAT, maps gamma rays over the entire sky every 3 hours and is GLAST's main detector. The other instrument is called the Gamma Ray Burst Monitor, or GBM. It looks for spectacular flashes of gamma rays from, among other things, the birth of black holes far across the universe. With the instruments checked out and calibrated, there was one formality left: give GLAST a proper name. From more than 12,000 suggestions, NASA christened its newest observatory the Fermi Gamma Ray Space Telescope. The new name honors Nobel Prize winner Enrico Fermi, a pioneer in high-energy physics and astrophysics. His work provided the first insights into the powerful processes the telescope will help us better understand. So, what are we seeing with the Fermi telescope? Here's a quick look. With its first 4 days of observations, the LAT proved itself the remarkable instrument we knew it to be. A detector on an earlier satellite took more than a year to record this level of detail. Much as a painter's brush adds life to a scene with each stroke, the LAT adds another layer of detail with every orbit. This bright band is the Milky Way, the plane of our galaxy. These gamma rays arise when high-velocity particles called cosmic rays collide with gas atoms in the galaxy's disk. A small fraction of these gamma rays may come from the mutual annihilation of exotic particles. Scientists have proposed such undiscovered particles as a possible explanation for mysterious dark matter. With our gamma ray vision, some sources glow especially brightly. These are pulsars, the dense, fast-spinning, and intensely magnetic leftovers of exploded stars. The Vela pulsar is the brightest persistent source in the gamma ray sky. Although we don't know all of the details, pulsars emit lighthouse-like beams of radiation. When a beam sweeps past us, we see the emission spike or pulse, hence the name. This animation of LAT images shows the on-again, off-again nature of the Vela pulsar. Its gamma rays actually cycle about 20 times faster than shown here. Most of the 1800 pulsars we know about were first identified by their radio emissions, but not this one, named Geminga. It was confirmed as a pulsar by X and gamma ray satellites. We suspect that there are many other radio-quiet pulsars like it. Their radio beams don't intercept the Earth, but their gamma ray pulses do. In fact, Fermi has already found one. It lurks in this expanding shell of gas, shown here at radio wavelengths, formed when a star exploded about 10,000 years ago. The shell is a supernova remnant called CTA-1. Everything about this X and gamma said it was a pulsar, except no one had seen pulses at any other wavelength. But Fermi detected them. This is the first pulsar ever seen that blinks only in gamma rays. It radiates more energy, in fact, in gamma rays than our sun does in all forms of light. This is just the beginning. We expect that Fermi will discover dozens of new pulsars within its first year. The telescope is also giving us new insights into gamma ray bursts and the massive jets that erupt from distant galaxies. Stay tuned. The mission of NASA's Fermi telescope is just getting started.